Hello everyone, welcome to my YouTube channel, Effective Coder. Today I'm solving the Leetcode question 4.7 Pacific Atlantic Water Flow. There is an m times n rectangular island that borders both the Pacific Ocean and Atlantic Ocean. The Pacific Ocean touches the island's left and top edges, and then the Atlantic Ocean touches the island's right and bottom edges. So basically it's a grid like this, Pacific Oceans and then Atlantic Oceans. The island is partitioned into a grid of square cells. You are given an m times n integer matrix heights, where heights RC represent the height above sea level of the cell at coordinates RC. The island receives a lot of rain, and the rainwater can flow to the neighboring cells directly north, south, east, and west, let's say 4 directionally adjacent cells. If the neighboring cell's height is less than or equal to the current cell's height, water can flow from any cell adjacent to an ocean into the ocean. So what does this last sentence mean? Which means, okay, so if water already flow to this cell, let's say the cell is adjacent to the Pacific Ocean, then the water can just flow directly to the Pacific Ocean. Same thing with the Atlantic Ocean. So basically, as long as the water can flow to the boundary cells, the water can flow into the ocean. Return to the list of grid coordinates, where the result I equals Ri and Ci denotes that the rainwater can flow from cell Rc, Ri, Ci to both Pacific and Atlantic Ocean. So what does this mean? So let's take a look at the example 1. So as described in the problem statement, this entire grid, m times n dimension, is an island, and then it's bordered by the Pacific Ocean and Atlantic Ocean. So basically, top and left Pacific Ocean, bottom and right Atlantic Ocean. The value represents the height above the sea level. So water can flow from a cell with higher heights. Let's say from here, D5 can flow into Atlantic Ocean. This can also flow to the Pacific Ocean. The water cannot flow from this cell with the value 3 to this cell with value 5, because remember, the condition for rainwater to flow is if the neighbor height less than or equal to the current cell height. So in this case, 3 cannot flow into a cell with height 5, but this cell 4 can flow into the cell with height 4 as well. It satisfies the condition. All the highlight cells here are the cells that the water can flow into Pacific Ocean and then also the Atlantic Ocean. We just want to return the positions or the coordinates for these cells. So how to solve this one? So we are solving it utilizing the depth first search algorithm, DFS. The idea is actually, the naive idea is, okay, take a cell here and then check if we cannot move, can we move to the Pacific Ocean and Atlantic Ocean? If this cell from here, we can find a path that reach the Pacific Ocean, and we can find another path that reach Atlantic Ocean. Then the rainwater from this cell can flow both into the Pacific Ocean and Atlantic Ocean, and then this cell is one element in our results. That is the, I would say, the native thought process or the naive thought process. However, so that idea encounters a problem. So how do we keep track of the if the cell hit the Pacific Ocean, and then keep track of the cell reach the Atlantic Ocean, and then how do we define the return value to indicate, okay, if this cell has already reached the Pacific Ocean, or if this cell has already reached the Atlantic Ocean? What if the cell reached the Pacific Ocean first? Shall we stop the traversal, or shall we continue the traversal until the cell reach the Atlantic Ocean? So it's a little bit complicated to think that way. So the simpler idea is actually utilize reverse thinking. So instead of starting from a grid cell and check if it can reach Pacific and Atlantic Ocean, we start from a boundary cells. So we know that, okay, the cells in the top row or the cells in the leftmost column can definitely reach the Pacific Ocean. So we start from the boundary cells and move. So while we move, for all the cells we can traverse to, we just add those cells along the path into Pacific or Atlantic sets respectively. So let's say we start from the cells adjacent to Pacific Ocean, and then we move, and then all the cells encountered, we know that, okay, all the cells along the path can flow into the Pacific Ocean. Similarly, if we start from the rightmost column or the bottom row, basically the cells adjacent to Atlantic Ocean, and then we are trying to move, and then the cells along the path can flow into the Atlantic Ocean. And then in the end, we got the cells that can flow into the Pacific Ocean and the cells that can flow into Atlantic Ocean. We just take the intersection of these two sets so that we can get the cells that can flow both into the Pacific and Atlantic Ocean. So that's the idea for solving it. Let's start coding. So get the dimensions for this height matrix. And then we initialize a set called Atlantic. So basically this indicates all the cells. So basically we utilize this one to store all the coordinates of all the cells that can flow into Atlantic Ocean. Similarly, we have one for Pacific. And then we define our DFS function. And then in this case, we also pass a visited set. So why we are passing the visited set? Because we want to reuse this DFS function for both checking the Atlantic and the Pacific. So each time when we check for Atlantic, the visited set should be Atlantic. When we check Pacific, the visited set is Pacific. So that's why we pass the visited set. If this cell has already been visited, then we just return. Otherwise, we get the new coordinates of the neighbors. So basically we get the coordinates for the neighbor, for all the neighbor cells in 4 directions. If the neighboring cells are within the boundary, and then also, if we can, the only way we can travel to the neighboring cell is that the height satisfy the condition, which means that if we are utilizing the reverse thinking, so basically height ij should be less than or equal to the heights of the neighbors. So basically, let's say we are starting from the Pacific Ocean. So if the water, let's say if the water can flow into the, let's say we're starting here, if for the water to be able to flow into the Pacific Ocean as we travel along the path, the cells we encountered later in the path should have a height greater than or equal to the cell we already encountered in this path. So in this case, if this 2 is less than or equal to 3. So in that case, the water can flow from this grid cell with value 3 to this grid cell with value 2 and then flow into the Pacific Ocean. And then we do DFS and I and J and also visited. So basically that's our DFS function. And then remember, we are doing this one in 2 iterations. First iteration, we start from the Pacific Ocean. And then in the second iteration, we start from the Atlantic Ocean. So let's do the Pacific Ocean first. So for Pacific Ocean, it added the top row. So in that case, I equal to 0. So basically for I in 0, actually that's for J. Let's say for J in range N, we call DFS for the row index 0. And then we pass the visit set Pacific. So in this case, basically that's represent the first row, the Pacific Ocean. And then we also do for the index, the row index equals m-1 and J. Here we start from Atlantic Ocean. So that's this row. So we start from the bottom row at the Atlantic Ocean and call DFS. And let's do it for the column index. So for this one, we iterate through the row index, and then we check the column index equals 0. So basically that's the leftmost column. We start from Pacific Ocean. Or we check the rightmost column. We start from Atlantic Ocean. And in the end, after we finish traversal, we just let's specify a result. For the cell in Pacific, if cell in Atlantic, just result dot append cell, and then we can just return the result. Oh, the time limit exceed. Okay, so in this DFS function, I forgot to add the ij into visited. So basically visited dot add ij. So okay, so the line missing here is the line 21. So basically after I check if I have visited the coordinates ij, if it's visited, we just stop traversal and return. If this ij hasn't been visited, then we add it to the visit set. And then we start visiting its neighbors. Okay, so this is actually a pretty efficient solution. So there is a small optimization. Basically, for the last uh, 4 lines, we can just replace this one, return list, Pacific and Atlantic, to return the cells that appear both in the Pacific set and the Atlantic set. Yeah, this is the end of the video. If you like my video, please don't forget to subscribe to my YouTube channel. That would help a lot. Thank you.